Have you ever wondered about the peculiar rules governing the quantum world, especially when it comes to observing tiny particles? It is a realm where things can exist in multiple states at once until we look at them. This concept often leads to profound questions about how our observations influence reality. Yes, Erwin Schrödinger was indeed highly skeptical of the concept of wave function collapse, particularly its simplistic interpretation as a real physical process tied to observation. His famous thought experiment, involving a cat in a box, was specifically designed to highlight what he saw as the problematic and even absurd implications of this idea. At its heart, wave function collapse describes how a quantum system, initially existing as a superposition of possibilities, suddenly settles into a single, definite state upon measurement. Schrödinger found this notion deeply troubling. He argued that if a tiny quantum event, like the decay of a radioactive atom, could remain in a superposition of decayed and undecayed states until observed, then a macroscopic system dependent on it, such as his hypothetical cat, should similarly exist in a superposition of both alive and dead. He did not believe this was physically plausible for a real, living animal, using it as a reductio ad absurdum to expose what he viewed as the vagueness and conceptual difficulties surrounding the so-called measurement problem in quantum mechanics. Understanding Schrödinger's skepticism helps us grasp a fundamental challenge in quantum physics. How does the classical, definite world we experience emerge from the fuzzy, probabilistic quantum realm? His critique forces us to consider different interpretations of quantum mechanics, some of which propose alternative explanations for observation, avoiding a true collapse altogether. For example, the many worlds interpretation suggests that all possible outcomes of a quantum measurement are realized in different, branching universes, while other theories propose objective collapse mechanisms independent of an observer. His work emphasized that the transition from quantum probabilities to classical certainties is far more complex than a simple collapse suggests. Schrödinger's thought experiment was not meant to be a literal proposal for a cat's existence, but a powerful intellectual tool. It was an epistemological metaphor that laid bare the quantum measurement problem, which remains one of the most debated and unresolved issues in theoretical physics even today. The concept highlights the deep philosophical implications of quantum mechanics and underscores that measurement is not a passive act in the quantum domain, but an active process that fundamentally alters the system being observed. Ultimately, Schrödinger's deep skepticism, embodied by his iconic cat, compels us to look beyond simplistic explanations of quantum phenomena. It serves as a constant reminder that the nature of reality at its most fundamental level is still subject to intense scientific inquiry and philosophical debate, pushing physicists to develop more complete and consistent descriptions of how our universe truly works.
If quantum tech fascinates you, like, subscribe, and keep exploring with us.